Hello students, and welcome to the first part of the air pollution lecture series. In this lecture, we're going to be talking about the nitty-gritty of how air pollution works, the different types, and specifically about nitrogen, sulfur, and carbon oxide pollution. All right, so just a few statistics for you. The World Health Organization, and this data is from 2016, which is the most recent I could find on a recent search, that outdoor air pollution, they call that ambient air pollution, contributes to 7.6% of all deaths each year in 2016. And that amounts to about 4.2 million deaths annually. They estimate that about 9 out of 10 people breathe air with high levels of pollutants, and that's at least some of the time. And 80% of people living in urban areas are exposed to pollution levels that exceed the WHO guideline limits. And so people living in urban areas are most at risk for air pollution. This is a map, and I didn't put up the legend, but you can kind of get a quick look at which countries suffer from worse air pollution compared to others. And there's all sorts of reasons for this, but in general, your more high poverty countries are going to have worse air pollution issues. So before we can really talk about air pollution, we need to talk a little bit about the atmosphere. We kind of skipped over some of the basic atmospheric stuff that we were supposed to have in a prior unit. So just really quick, the lowest layer of the atmosphere, also known as the innermost layer, is called the troposphere. This is where all weather occurs. It contains 75% mass of the Earth's air. It's the location where the greenhouse effect goes on. And it's heated mostly from beneath, not from above. The sun's energy comes in, hits the Earth soaks it up, re-radiates it as that infrared heat. And so generally you think that our heat comes from the sun, but really what's heating the troposphere is the Earth itself. And you guys already know this because you live near mountains, but as you go up in altitude, the temperature decreases. And this little red line on the graph is the one that shows you the temperature profile. So really strangely, the difference between the troposphere and the stratosphere is not some arbitrary boundary that somebody put in. It's actually a physical boundary. The stratosphere is where the ozone layer is, and starting in the stratosphere, you actually get an increase of temperature with altitude. So opposite of what you're thinking, but even our tallest mountains are still in the troposphere. Our airplanes fly close to the edge of the troposphere stratosphere boundary, known as the tropopause, but they still fly in the troposphere. So up in the stratosphere is where the ozone layer is, and we won't be talking about ozone in this lecture series in the stratosphere. We will, however, be talking about tropospheric ozone, which means ozone close to the ground where it can do you harm. We actually like ozone in the stratosphere because it's what it protects you from ultraviolet radiation. And again, there's this changing temperature profile with different layers of the atmosphere is actually a bit of a complicated topic that we don't need to go into for this environmental science lecture. So different types of pollution. There are primary pollutants and there's secondary pollutants. And the difference between the two depends on, is it put directly into the atmosphere from people, or is it something that's created in the atmosphere when those primary pollutants react with other things? So primary pollutants are things like carbon oxides, sulfur oxides, and nitrogen oxides. The little x means that it stands for any integer. So for carbon, it'd be carbon monoxide, carbon dioxide. For sulfur, there's SO2, SO3, and for nitrogen, NO2, NO3. All right, the other things that count for primary pollutants are hydrocarbons and particulates. Secondary pollutants are things that are created up in the atmosphere through chemical reactions. Most commonly, things react with water and make acids. So when you look at this little secondary pollutant list over here, you see sulfuric acid, nitric acid, there can be some carbonic acid, but other things can also be produced up there. And there are these things called PANs, because who can say periacyl nitrates, and ozone is also an example of a secondary pollutant. So secondary pollutants, again, are formed in the atmosphere, and they're going to be the focus of one of our later lectures, not this first lecture today. When you look at different pollution, when we think about particulate matter, those are suspended particles. So they're not gases, they're actually like particles, like when you think soot, that would be particulate matter. But not all particulate matter is created equal. And what I mean by that is that particulate matter depends really largely how damaging it is to you based on its size. And in general, the smaller it is, the worse it is, because your body has certain mechanisms that can keep that air pollution from getting inside you The smaller it is though, the deeper it can go. So when you think about the small particles, these are going to be the more harmful to you. As you go up to the large particles, those are often caught by little hairs in your nose and throat, and you can cough them back out again. But the really small particles can make it deep into your lungs, and your body's defenses doesn't really have much in the way of defenses to stop those. So what are our sources of particulate matter? Coal burning power plants put out a certain amount of soot, even though we try to clean those up. Motor vehicles, you can see this truck, this is really a nasty example of it, but if you've ever been behind a school bus and that diesel fuel puts out a lot of particulate matter. Fields, plowed fields, that dirt that gets kicked up, unpaved roads, if you've ever driven behind somebody on a dirt road, tobacco smoke, those are all sources of particulate matter. So here's just some examples. Diesel vehicles in general are pretty dirty on the particulate matter. It's not as clean a fuel source as regular gasoline powered cars, at least as far from a pollutant type matter. It's different when you're talking carbon dioxide. And again, when you're looking at diesel soot maps of the United States, just anywhere you have your major cities, you're going to have a diesel problem. Anywhere you have major trucking, and we're a major port city here in Seattle, so we have an awful lot of trucks that come through the city every single day. They pick up material that comes in by ship, and they ship it off to other parts of the country by truck. All right, I tried to find an updated graph and I couldn't find one that had it laid out so nicely. But basically the good news is that we have done a lot about air pollution in our country. So this is our change in air quality index from 1980 to 2008. And you can see we actually banned lead back in the 70s, but it took it a while before it got out of the air because we were still driving those leaded gasoline cars. But as soon as those cars kind of aged out of the system, our lead pollution went way down very quickly. But look at our other pollutions, nitrogen, sulfur, and carbon, they have all come down significantly over time. So this is kudos to our Clean Air Act, which set air quality standards. And we'll be talking more about that act, I think, in the last part of this lecture, the lecture series, part 4. Here is a map that shows what are the sources. So for carbon monoxide, nitrogen, VOX stand for volatile organic compounds. When you're talking about particulate matter, they use the word PM for particulate matter, and then the 10 is the size of that matter in microns. PM, anything less than PM10 is considered pretty harmful, and even more harmful is if you go to that PM 2.5, that means that they're smaller than 2.5 microns. But when you look at the sources, you can see that transportation is a large matter, at least for a lot, like these things are all going to be car related, truck related, etc. The exceptions to that are sulfur, and for that one, it's other fuel burning. And when you think sulfur, think coal burning plants. Coal has a certain amount of sulfur in it, and when you burn it, that sulfur can get out. And then the particulate matter is actually kind of evenly split between the non-energy sources, fuel burning like coal, and then transportation. We're going to start with nitrogen pollution. There are different kinds of nitrogen oxides, NO, NO2, and NO3. So NOx can stand for any of those. The natural sources, bacterial action in soils makes up 90% of all that nitrogen in the atmosphere. So what are our anthropogenic sources? Combustion engines. And you might be like, wait a minute, we're not burning nitrogen in our cars, but we'll look at this on the next slide as to why combustion engines put so much nitrogen into the atmosphere. And then anything that's going to combust fuels is actually going to put nitrogen in the atmosphere. So any kind of electric power generating plants and factories that are combusting things for fuel. So why is that? Turns out that nitrogen is, our atmosphere is 78% nitrogen gas. That is a triple bonded molecule, and anything that's double bonded is strong. Anything that's triple bonded is super strong. This is one of the reasons why it's hard for nitrogen to get from the air into the soil, is that you need like those microbes that can break that triple bond and fix that nitrogen in the soil. Similarly, nitrogen does not break apart very, very easily. So what you can do though, is if you put it in an engine and you bring it up to high enough temperatures, you will break that nitrogen and you will force it to combust, making a nitrogen oxide. Why are we pulling that nitrogen into our car engines? Because in order to burn our gasoline, we need oxygen. Where do we get our oxygen? Well, 22% of it's in our atmosphere. So we have air intake valves in our cars. And as it pulls in that air, you're going to pull in 3/4 of what you're pulling in. It's going to be nitrogen, and some of that nitrogen is going to combust. All right, and then what happens to it when it gets up in the atmosphere? So this is our primary. Then it gets up in the atmosphere and it reacts with oxygen, makes nitrogen dioxide, and then that reacts with water to make nitric acid or nitrous acid. And you can see there's various reactions. So that basically there's a big chemical soup up in the sky, and then there's a lot that goes on up there. So when you just, so you know a little chemistry, when you see the little word AQ, it means for aqueous, means dissolved in water, and versus when you see a little G, which stands for gas. So this is globally as of 2015, and you can kind of see the hotspots for nitrogen globally. And again, think of your big cities and where we may not have as many pollution controls. Also note that Europe doesn't look super great and for their nitrogen. And I'm not sure all the sources of that. I do know that they went to burning more diesel-oriented cars, but I'm not sure that would have a nitrogen effect. What is good news for us is this is a time-lapse map. And you can see that when it starts out super red, that's 2005. And then when the red gets smaller, that's 2011. So this is a time series. And again, this is just over 6 years. You can see how nitrogen has really dropped significantly in our country. So that's good news. So what are the emissions? What are we looking at? So motor vehicles, really huge, all that combustion engine action going on. Miscellaneous, whatever's left. Electricity production, again, those can be your natural gas-fired plants, your coal-fired plants, and then industrial processes. And the size of the pie is related to the size of how much is getting emitted. So from 1994 to 2010, you can see that the nitrogen dioxide going up in the atmosphere has dropped quite a bit. This is a great little chart, and I believe I gave it to you just straight in your notes because it basically shows, okay, what are the compounds, what are the sources, and then what are the environmental impacts. And whenever you're thinking air pollution, think respiratory effects. And so you can have irritation, difficulty breathing. Nitrogen oxide, we're also going to be getting to this in a later lecture, is one of the components of photochemical smog. And that's exactly what it sounds like, is that the sun can cause reactions in the atmosphere and cause other types of smog. And then again, it has, it's kind of a component of several other types of pollutions. And then of course you can react with water vapor to make nitric acid. But when you think of acid rain, nitrogen's not the culprit you should be thinking of. You should be thinking about sulfur. So that was a good segue to the sulfur pollution. The SOx for sulfur, you're looking at sulfur dioxide and sulfur trioxide. For natural sources, as you probably know, because you live in a fairly volcanic area, volcanoes, they actually put out quite a lot of sulfur. If you've ever been to Hot Springs or been near Yellowstone, any of those places, you know that already. But if you've ever smelled that sulfurous smell near the ocean, turns out ocean water has quite a bit of sulfur, so sea spray can get that sulfur in the atmosphere. And then microbes release it from soils and such too, so you get biogenic releases. For anthropogenic sources, again, think coal plants. All right, so stationary fuel combustion, especially coal, but also if you have oil burning power plants. I have an oil heater, as you know, in my house, and I know that one of the impurities in that oil heat will also be sulfur. And then we'll talk about what this is, but smelting of ores. Ores, it turns out that most metals are found naturally on planet Earth as sulfides. And in order to get the metal out of the sulfide, you have to take the sulfur out. So we'll get to that on a future slide. Looking at this, again, our sulfur has come down, and this is mostly due to the decrease in coal burning over the last decade or so. And that's really good news. So I feel that there's absolutely no reason why we should be burning coal anymore as a country or even as a planet. And so we need to phase it out. There's so many reasons why coal is bad. Sulfur is one of them. Mercury is another, the particulates that come out of it, the toxic coal ash. We have other solutions. And even if we need to use natural gas as a different fossil fuel in the meantime, I believe that coal needs to go. Natural gas is not going to have sulfur in it. All right, I'll get off my soapbox and move on to some other things. So what is sulfur oxide pollution? There's something called industrial smog, and it's sulfur dioxide, sulfuric acid that comes out of, factories, et cetera. And let's go through the two different types. So the primary is sulfur reacts with oxygen in the combustion process, and you get sulfur dioxide. So that's the primary pollutant that goes into the atmosphere. Once it's up there, it goes through a series of reactions, and one of the main products you should be thinking about when you think sulfur pollution is sulfuric acid. And then in the smelting process, I use zinc as my example. Would be zinc sulfide. And in order to get the zinc free, you have to react with oxygen and you extract the zinc, and what is a byproduct is sulfur dioxide, which then can go back in the atmosphere and make your sulfuric acid. All right, so about that smelting, a little bit more detail. It's a chemical process used to purify a metal ore. And as again, like literally, nearly every element I can think of, metal, comes as a sulfide naturally occurring on planet Earth. So there are just a ton of them. In fact, there are very few metal ores that come as non-sulfides. Gold is one, titanium is another, and otherwise aluminum is a third. But really, practically every, I'm a geologist, practically every other metal out there comes as sulfides. So, you know, it's again, it's very rare. Ooh, I forgot chromium. All right. So the problem is then is that if you want that metal for whatever, copper for your copper pipes, etc., you're going to need to run it through some reactions. And what the byproduct is going to be that sulfur. If you're chemically separating the metal from the sulfur, that sulfur is going to come off. All right, so just a little history, because you might be like, okay, but can't we fix that? And the answer is yes. We have our own little backyard history here from, there used to be a big smokestack in Tacoma from the ASARCO Smelting Company that was based out of Tucson, but they had their own smokestack, a big factory in Commencement Bay, which is in Tacoma. It was erected in 1917 and it was the tallest in the world. And one of the reasons to build them tall was they knew the stuff coming out of those things were really nasty. But the idea was if you could launch it into the air at a high enough height, it would spread out before it ever came down and like suffocated or poisoned people. So from like almost 100 years, ASARCO deposited just tons of pollutants. So the slag was the other byproducts from their processes, and they deposited it in the bay and on their property. And now those are Superfund cleanup sites. But in the meantime, they sent a whole lot of stuff into the atmosphere. So again, for these years, they smelted lead, and then they switched to copper smelting until 1985. So this all happened before you were born. So why should you care? Is because to this day, Mercer Island is polluted because of the ASARCO smelting plant. So in the 1940s, they poured all of this stuff, and then our Elliott Bay is polluted also because of all the stuff they poured into the water. So 15 million tons of slag, and that's full of heavy metals, things that are very poisonous to sea life, etc. The soils are just completely destroyed in that area too. So again, what is it? What kind of metals are in there? Arsenic, cadmium, copper, lead, zinc, all of those nasty things. Today, it's a major Superfund site. ASARCO, I think, went bankrupt. They were not able to clean it up themselves. And so what it means when you say something is a Superfund site, it means that it falls on the government to do the cleanup work. So again, why should you care? They also emitted a ton of arsenic into the air during this time. So arsenic was not something they wanted, so it just went out the top of the stack. They took it down, they demolished it in 1993. So if you drive through the area now, you won't see that tall thing in the sky anymore. But this is the legacy of the ASARCO smelting plant. This is a fallout map of the ASARCO plant. And notice that Mercer Island is right here. And if you live on the south end of Mercer Island, you have levels that are considered maybe not safe for ingestion. So if you garden and you live on the southern half of Mercer Island, you should maybe think about having your soil tested. I live in this area over here, and it turns out I'm right on the boundary, and there can be very local effects too. So don't think if you live on the south end of Mercer Island that your soil is contaminated. It might be, it might not be. You need to get it tested. I live right by two schools, both of which were tested because every school in the area had to be tested. And it turns out my area is okay, but I kind of live right there. And it turns out people who have the more expensive waterfront property in West Seattle tend to have the more polluted, actually down here, more polluted areas. Vashon Island is pretty deeply impacted, and they're kind of known as kind of a hippie gardening community. And I wonder if they know how much arsenic is in their soils. There is a map you can pull up, and if you're interested, you can go to that website. I used to pull it up during class, and you could get a more up close picture as to whether or not your house has arsenic soil contamination. And you can do that on your own time if you'd like. All right, so final bit of the story. Again, there was just a huge amount of money that it would take to clean this up. They filed for bankruptcy, and there's a whole lot of cases that are still kind of pending. I haven't really looked at the most updated information on this, but basically ASARCO is like, we can't clean it up. So it's a Superfund site. All right, so moving along. They've been coming down in developing countries due to better emission control. So even for our coal plants that we still have today, we have put scrubbers and things on them to keep that sulfur from getting out in the atmosphere. It's just not a perfect process. And then, you know, people like me with my evil little oil burning furnace, I'm still putting sulfur out there. And you can see here just a map. You can also see again how just over time we have sulfur emission dioxide by state. This is just 2 years, 2014 and 2015, and you can actually see that we've come down a bit. And again, most of that is because we are phasing out coal. All right, finally, carbon oxide, and we're only going to talk about carbon monoxide because I believe we spent way more than enough time talking about carbon dioxide during our climate change unit. So realize they can go up, either of those can go up, and the thing we didn't really talk about too much was the idea of carbonic acid, except when it came into play with ocean acidification. All right, so what about carbon monoxide? It binds to your red blood cells, and it inhibits the ability of those cells to carry oxygen. So if you get carbon monoxide poisoning, you basically suffocate. So what are the sources? A lot of things that combust, or can combust carbon type things. So it turns out this is 1,000 residents over a 15-year period. And now it turns out all new residences must have detectors. And by 2013, all residents except owner occupied. So if you live in an apartment, you should have one of those. I have my own house and I have one and I still haven't set it up yet. And I probably should. So again, if you're owner occupied, they don't really regulate it. But if you're renting or if you live in a new house, they're required to have them. All right, so how can you prevent it? Never use a charcoal or gas grill inside. People tend to do this when the heat goes out, and that's not a good idea. Don't burn charcoal in your fireplace. If you do burn any kind of wood fire, make sure that you have your flue open and you get a good draft. And then never use a generator inside your home. Again, these things tend to happen when the power goes out for extended periods. And never use a gas range or gas oven to heat your home. And never sleep in a room with an unvented gas or kerosene heater. So how can you prevent it from motor vehicles? Don't be in a closed garage with the, make sure the door's open if you're running your engine in your garage. You should have your mechanic check out the exhaust system on your car every year, or at least, every once in a while when you get your major checkups. Don't let people ride in the backs of trucks, etc. And then don't use things inside. All right, so basically you should have things. I get my furnace checked out every year. So I get it, make sure that my furnace is running properly because I do have an oil burning furnace. And then don't use unvented fuel heaters. And if you suspect a gas leak, basically call 911. So that is the end of our first part on air pollution. And we will continue with the other 3 parts in a few minutes.